You can follow along with this presentation using printed slides from the NanoHub. Visit www.nanohub.org and download the PDF file containing the slides for this presentation. Print them out and turn each page when you hear the following sound. Enjoy the show.
So we're really pleased today to have Dr. Wereley here. I think John and I both heard him on NPR one morning and just thought, I think the morning of our last event, and thought, I wonder if we can get him, and we emailed him, and he said yes. He's been working as a mechanical engineering department at Purdue since 1999. He's written a book on particle image velocimetry, which I had never heard of. And I don't know if when he helped write this book or when he wrote this book, if he knew where it would take him today. So I'll let him explain all that to you. So with that, please welcome Dr. Wereley.
All right. All right. Thanks, everybody. Thanks for the introduction. I certainly didn't know what I was getting into when I wrote that book, co-wrote it. I think this is a really excellent venue. I've never given a lecture at a bar before, so it's a first for me. So this is, I'm going to tell you the story of this terrible disaster, and in particular my involvement in it. But this is an unfinished story at present, both from the disaster's point of view as well as from my involvement in it. So this may be a little unfinished. As you know, I mean, this is the first time that I will have talked about any of this outside of Congress, of course. But this is the first time, and most of this I wrote this afternoon. So, you know, that's just a big asterisk that I'm not sure what we'll get here. So. Okay, anyhow, I thought I'd start out with a couple of brief slides telling you what I usually do in my, in my research. Maybe I'll move this over here. So, really briefly, you may have seen the affiliation on the title slide. I'm in nanotechnology, microfluidics. And, certainly if you made a list of people that you would contact to help out assessing this spill, I would be down on the bottom of the list somewhere. Because nanotech, I mean, it's just not a likely overlap. So I don't know if you can see this, but one of the things we do is manipulate particles. We move them around with lasers and electric fields, and so you can see this. This is a little 10 micron particle. It's about the size of a cell in your body. Give you an idea of length scale. Here's another example. And what we have here we have these two electrodes, and they're oriented like this. And there's an electric field between the two electrodes. And I use a laser. You can see down here on the bottom, I'm coming in with a laser. And what I can do is manipulate particles with this sort of technology. Let's show you a video here. Maybe we'll do that next time. This is the eternal problem with Windows PowerPoint presentations. Every single conference I've been to, there's somebody who can't run their videos. So today it's me. Anyhow, what this shows you is this is a large cloud of 1 micron particles that we manipulate again with light and electric fields. And, I think people don't have a real good sense of what a micron is. It's, a micron is smaller than any of the cells in your body. So, really small stuff. And this is worse. These are 50 nanometer particles. So that's even still smaller. So definitely not a macro scale person. So a segue here. This is another, some measurements that we did a while back. Flow around a red blood cell. And what you see in the center of the picture here is an image of a red blood cell. So this is a red blood cell that was kindly donated by a postdoc You know, there are very strict university regulations about human test subjects, but there are the regulations about having an accident and accidentally bleeding onto a slide are slightly smaller. So this belongs to my friend. We were both postdocs at the time, so I didn't pull rank on him or anything. He just drew the short straw. This belongs. This is Juan Santiago's blood cell. But the reason this is a good segue is we're measuring the flow around this red blood cell, and what you may have a hard time seeing is lots of arrows that point to and indicate the magnitude and the direction of the flow around this blood cell. This is a measurement technique that I use in my research, and it happens to be the topic of that book that we just mentioned, particle image velocimetry. So, you know, I've used it for something approaching 20 years. I've used particle image velocimetry to measure one thing or another and co-authored the book. It's called Particle Image Velocimetry, Fundamentals and Principles. So, that's a segue to the book. So here's the picture of the book. And this was my sabbatical activities in 2007. I went on sabbatical to Germany, and well, you probably can't read the co-authors here, but they all have German names. It was a team that worked at the German Aerospace Agency, and I happened to. They wanted to go in the micro and nanotechnology direction, and so they brought me in as a fourth author on the second edition. So, happened to be a really important move for me, as fate would have it. So we'll move on. Oops, that's the laser. Sorry if I just shot you, Ryan. I did write another book, but this one's just immaterial here. All right, so this particle image velocimetry technique, I'll tell you a few things about that. First of all, it's an image-based method for measuring flows. And that's important because what it means, because it's imaging based, you don't have to stick anything into the flow in order to measure it. You just look at the flow. You look at small particles that happen to be carried by the flow. Sometimes we put them in there, sometimes they happen to be in there already. And so it's very non-intrusive. And the important thing, you know, when we think forward to this disaster, is that it's what I would call a standoff technique. And that's important because it's very difficult to stick things into a rushing stream of oil. So we just take pictures of flows and we can measure them. One thing that became very important in this, in the debate about whether the measurements that I and other scientists made, is whether we were using some, you know, wacky fly-by-night technique that I just thought of and, you know, thought I'd give it a shot. And so the important thing is, well, no, it's not that. You know, it's been used for about 25 years. In fact, I saw Warren Stevenson here, who was, I think, involved in the early days of particle image velocimetry. And there are thousands of practitioners worldwide. I mean, at Purdue alone, there's got to be at least 10 people who are really good at it, and a bunch more who, you know, who do it as end users. So, you know, it's definitely a well-established technique, yeah, so not something I just invented. All right, so when we do this in a lab setting, you get incredible accuracies, up to 1%. I mean, really, really good technique.